We are going to start this year by learning about the scientific method, and this is your first lesson. So today we're just going to go over the steps of the scientific lesson. And then as we go through the unit, we'll learn a little bit more deeply about these specific pieces, okay? So today we're talking about how do we ask a question? How do we ask a scientific question? A good scientific question must always be testable and it avoids opinion. So something that would be testable would mean, like, can we do an experiment on it? Can we test this question? So we could say something like, does handling frogs cause warts? We know what we're going to handle, frogs, and what they cause, warts. Instead of saying, can an animal mess up your skin? This is not specific enough, okay? So we always must have it be testable, be specific, and it has to keep the scientists focused on one experiment. Frogs and warts. We don't want to be testing frogs and warts plus maybe ducks and geese and horses and mice. Too many things. We've got to be focused on one experiment, okay? Once we get to this question, we have to make sure that it avoids opinion. We can't ask things like, which flowers are prettier, daisies or roses? This can't be tested. It's an opinion. A better question might be, do daisies or roses grow faster? Now we know what we can test. We can test this type of flower and how fast it grows and compare it to another type of flower and how fast it grows. Okay, so it's specific, it avoids opinion, it keeps us focused on one thing, and it's always, always testable. Okay? So when we look at these testable questions, let's see, is this a good scientific question? Does hot water freeze faster than cold water? Is this a good question? Sure, it's testable. We can freeze hot water, make it nice and cold, and we can time how long it takes to for hot water to reach that frozen temperature, and we can compare that to the cold water, okay? And then we could get a specific result. Do cats make better pets than dogs? Not something that's testable. This does not avoid opinion, okay? So we don't know what better is. We don't know what kind of breed we're talking about. It's just generally not a good scientific question. But we could rewrite it and we could say, are dogs or cats more likely to come to the door when you come home from school or work? This is something that you can test. You can try it each day with a dog, take tallies of how many times they come and greet you, and compare that to a cat. That would be a testable scientific question. And then we could form a hypothesis. Okay, so a hypothesis takes into account the variables. Now we're going to talk about variables more in depth later on, but this is just a quick little intro. An independent variable is the thing that the scientist is going to change. It's going to cause something else to happen, okay? And then the dependent variable is whatever we look at, whatever we measure, whatever happens as a result of our change, okay? So independent variable, I remember that as I. Independent, I change something to see something else happen. This is dependent on what I change. Okay, so a helper sentence would be the scientist changes the independent variable to see a difference in the dependent variable. I make a change, something happens, and then I observe that change. So we could say that a hypothesis is written as if independent variable, then dependent variable. If I add water to my roses, then they will grow. I'm measuring the growth of my roses, and I change the amount of water I give them. I change the amount of water to see a result in the rose growth. Okay, so would this be a scientific question? Does drinking soda make you run slower? Yeah, we could test that. We got to know, what background research do we know about this? Well, I know that drinking soda might cause me to be dehydrated. I don't know that I might get stomach cramps if I'm dehydrated with a lot of carbonation in my belly. Might not be able to run fast, so it's plausible I would run slower. I might be able to write a scientific hypothesis by saying, if I drink soda, I will run slower. All right. So now we're going to go over to the materials. In every scientific experiment, and when we use the scientific method, we'll always have to gather our materials. When we're writing our lab reports, these are written as bullet point lists, okay? And you want to be as specific as possible when you are listing your materials. Likewise, when you write out your procedure, you want to be as specific as possible. But instead of writing this as a bullet point, procedures are written as steps. So step 1, step 2, step 3. All right, and then next, we're going to discuss the analysis and conclusion sections. So after we've written our question, we've come up with our variables, we've formed that solid hypothesis, we've gathered our materials, we've written our steps to our procedure, we've carried out our procedure, we've collected our data. Now we got to talk about looking at our data and drawing conclusions. And again, we're going to have other lessons later on that discuss this more in depth, but here's just a quick overview. So data is the information that we gather from our experiment. We must constantly be collecting and recording data during the experiment. And we can organize this data in a table or a chart. Sometimes we'll use a graph to illustrate the results after it's organized in that table or chart. We can use all sorts of different kinds of graphs. We can use bar graphs, line graphs, circle graphs. All of these things are great at representing our data depending on what it is that we were measuring and how we want it presented. Once we get that data into a graph, it's time to analyze it and really think about what is it showing me. Okay, just because data collected does not prove the scientist's hypothesis, it does not mean that we did the experiment wrong. That just means that the hypothesis wasn't correct. And that's okay. That's the point of an experiment. We don't want to be right all the time. What fun would that be? So make sure that you're looking at your data very, very carefully. So then the last thing that we would do is before you write a conclusion, you got to take some time and really think about what you're shown. And then think about, is this valid? And does it support my hypothesis? And then you can write a great conclusion saying, I can reject my hypothesis or I can accept my hypothesis. Okay? And that's it for today's lesson, you guys. If you have any questions, please reach out. Bye-bye.